this is John from caveofprogramming.com, and in this tutorial we're going to look at upcasting and downcasting in Java. So I'm going to start by creating a couple of classes here. I'm going to create a class called machine, and I'm going to give this one method, public void start, and I'm going to put some implementation in there. I'm just going to put sysout with machine started, like that. And then I'm going to create a child class camera, and I'm going to say camera extends machine, because a camera is a kind of machine. And I'm going to override this method, so let's just copy it and paste it in here and change this to camera started. And I'll give camera another method of its own, public void snap, and let's say here sysout photo taken. Now let's create a couple of objects of the type camera and machine. So machine, I can say machine 1 equals new machine, and I can say camera 1 equals new camera. And of course I can call the methods on these, so I can say machine 1 dot start and camera 1 dot start and camera 1 dot snap. So let's just run all that stuff and make sure it works as expected, which is always good. So there we go. And now let's take a look first at upcasting, which is the simpler case in some ways. So I'll put a comment here, upcasting. Now upcasting and downcasting, or casting in general, is a thing you do with variables basically. Once you've created an object, like an object of type machine or camera in this case, those objects are always going to be whatever they are to start with. The machine will always be a machine, the camera will always be a camera, but you can change the variables that refer to them from one type to another. So as an example, we saw in the tutorial on polymorphism that you can always use an object of a child class type where you would expect a object of a parent class type. So machine is the parent class, and if I say machine 2, I could set that equal to a new camera quite happily, and this is polymorphism, and we know that that's going to work. But what I could also do more subtly is we see here that camera 1 points at a camera, so I could set the machine 2 variable to refer to the same object that the camera 1 variable refers to, which is this object here. So I could say machine 2 equals camera 1. And what I've done here in effect is, well, I've taken a variable of type camera that refers to a camera object, and I've made this variable of type machine refer to that object. So we say that I've upcasted, or I've casted this reference, this variable, to this variable type, and it's up because we've gone up the class hierarchy from camera to machine. So this is referring to a camera, and I've taken that camera object and I've made a variable of type machine further up the class hierarchy refer to it. And now I can say machine 2 dot start, and if I do that, which start method is going to be invoked? Well, the answer is it depends on whatever object that machine 2 refers to, because the methods and the implementation, the guts of the actual code that actually does stuff, is not stored in the variable, it's stored in the object, and the variable, the reference variable, merely refers to that object. If I thought that this was going to call the start method in machine, it would be like having a label that I've stuck on my car that says my car, and then expecting to be able to drive the label, because it's the car that actually does stuff, it's the object that actually does stuff. So when I call machine2.start, then it's going to call this camera method, because the actual object referred to by machine 2 is a camera object. So if I run that now, we can see here it says camera started. That's upcasting, and now you notice that okay, camera has this method snap, but I can't say machine2.snap, so the autocomplete isn't helping me, and now I'm getting an error here, and it's saying the method snap is undefined for the type machine. And the reason for that is that it's the actual variable that decides what methods you can call. The variable knows what methods are available for that variable type, and the variable here, machine2, is of type machine, and a machine only has a start method, so this variable will only let me call the start method. It won't let me call camera methods, even though it is referring to a camera. But we'll see in a minute that there's a way around that. And so the important thing to remember here is that the variable declares the type of the variable, determines what methods you can call, but it's the type of the object that that variable refers to that determines which actual methods, like which actual implementations will actually be called when you call that method. So let's take a look now at the converse of this, downcasting. So I'll put a comment here, downcasting. And let's again have a variable of type machine. Let's call this machine 3. And again, let's make it refer to a camera like this. So I can't call machine3.snap. That won't work. But I know that machine 3 is referring to a camera, and that camera does have a method called snap. So of course I could think, well, there must be a way of calling that snap method, and there is. Because I can say here, I can declare a variable of type camera. Let's call it camera 2 now, and I can set that equal to machine 3. In other words, I can set that equal, I can set camera 2 to refer to whatever object machine 3 refers to, which is this camera object here. And now I'm getting an error here, and it's saying cannot convert from machine to camera. And the reason for that is when you downcast, Java wants confirmation that you actually know what you're doing, for reasons that we'll see in a minute. And to give it that confirmation, you need to put the type of the variable that you're casting to in brackets before the variable that you're casting from. So I'm casting a variable of type machine to a variable of type camera. So I have to put camera here in front of machine to match this. And now I can say camera 2.snap like that. And of course if I say camera 2.start, of course that's going to call the method in camera, because the object all along was a camera, so they've got photo taken and camera started. Now the reason that Java wants this confirmation here is because unlike upcasting, downcasting is inherently unsafe, because I could say here machine 4 equals new machine. Okay, that's fine. Now I could think, okay, I could forget that that's a machine object, and I could say camera 3 equals, and I could try to cast this to a camera. Let's put some brackets in there, camera, and I'll put machine 4 here. And now I'm not going to get a syntax error there. It's giving me an unused variable warning. Let's try to use it. Camera 3.start. And what's going to happen when I actually run this code? So I run it, and I've got an exception, and it's saying class cast exception, machine cannot be cast to camera. And if I click on the error line here, so you should always read exceptions from top down, and the first line, in fact the only line with a line number on it here, is this, and here's where the problem occurred. So I can't do that because this is like saying, basically I could also have tried to call camera3.start and that wouldn't work either. oh sorry, not start, but snap. And the reason for this is that that the actual object here is a machine. So I can't just change the machine object into a camera. Objects are what they are, they don't change. And when I start trying to call the camera version of start using a machine object, or when I start trying to call camera methods which machine doesn't have, then I've got a problem, and you only see the problem at runtime. So this doesn't work. Let's say runtime error. And let's just comment this out so that if you look at this code on caveofprogramming.com, you'll find that the program at least runs. Well, actually I need to comment this out as well, because that's where the error is. There we go. So you can't do this, and so here, like we see, upcasting is safe. That's guaranteed by polymorphism, and you don't need a cast there. But you don't need an explicit cast in brackets. But downcasting is inherently unsafe, and you have to really think when you're doing downcasting, and you want to be really sure that the variable you're downcasting really does refer to an object of the type that you're downcasting to. And by the way, you can't downcast between unrelated types, again for the same reason that you can't downcast a machine object to a camera. Because you can't change one object to another object. All you can do is change the references, and the references then depend on the underlying object, which doesn't change to invoke the correct code. So that's upcasting and downcasting. It's a tricky subject that can take a little while to get your head around, but it's really important to know, especially since you often find methods that return an object that have a return type of object, but the real object underneath is some specific child object, and then you need to cast that object into the right type to actually use it. But I don't know if it's really worth looking at that here. Probably not, so I'll leave that. But be aware that it's quite common in Java to cast an object which is the parent of all objects in Java, or the grandparent or whatever. It's really common to cast objects to objects further down the hierarchy, but you have to be sure that the object variable that you're casting really does refer to the kind of object that you're trying to downcast to, otherwise you will get an error at runtime. So that's upcasting and downcasting, and as far as I can think, we've now covered everything that we need to look at using generics. So probably in the next tutorial we're going to look at generics in Java. So join me again then, and you'll find this code on caveofprogramming.com. And until next time, happy coding.